Hello friend, welcome back to my video. In this video I am going to talk about significant figure and error analysis. Significant figure, as you can see, it defined as a significant figure arises out of the measurement from instrument which comprise of all certain digits plus one uncertain digit. As you can see in this scale, there is 1 centimeter, 2 centimeter, 3 centimeter, and we are measuring a line whose length is 1.6 and 5 per bar. Here the significant figures are 3. If the scale is like this plane scale where 1 centimeter, 2 centimeter and 3 centimeter are there, then length can be measured like 1.6 bar centimeter or 1.8 bar centimeter. The significant figure will be 2. So the first scale can measure the 3 significant figure, whereas second scale can measure only 2 significant figure. Now, rules of writing down significant figure. First rule is all non-zero digits are significant. Whatever the non-zero digit will be present in the measurement, that will be significant. Rule 2, any number of 0 between two non-zero digits are significant. Like here, length is 1.07 centimeter. Thus here 0 will be significant figure because it lies between the significant digit. Meaning any number of 0 between two non-zero digits, it is non-zero digit. That is why it is significant figure. Rule 3, any number of leading 0 are non-significant. 1.65 centimeter, we are converting it into kilometer, then 1.65 by 10 to the power 5, and this will come out like 1.4 times 0, 165. These 4 zeros will be not zeros are leading zeros. That is why it is non-significant. All lagging zeros in the measurement in a number without a decimal point are non-significant. Like all lagging zeros at the end, if there is a 0, then the measurement in the number without a decimal point are non-significant. And there is no decimal point, then it is non-significant. 16500 micrometer, then 00 will be non-significant. We have to take 165 as significant here. And 3 significant figures are there. 5, any number of lagging 0 after the decimal point are significant. Lagging 0 after the decimal point, like here 2.00 centimeter, then it will be significant. Or for example 1.65, here it is 3 significant non-zero number are there, that is why it is 3 significant. Here is the 1.007, as I have discussed earlier. These are the cases. Now here, as the question shown in the figure, 2850 centimeter, here significant digit will be 3. 100 meter, the significant digit will be 1. 100.2 meter, then significant 100 point only is there. 100.0 there will be, then there will be 4 significant. That is 100 point, then 3 significant. 0.001280 kg, significant digit will be 4 by 0.00 will be not significant, but 1280 will be significant. 0.02030, then 2030 will be significant digit, then significant digit will be 4. Rules of addition of significant figure. The number of significant digits in the sum after the decimal place is equal to the least number of significant digits after the decimal place among the measurements which are being added. As shown, 1.2375 bar, 4.75 bar. If we are adding it, then it will come out 5.98 bar, 75 bar. And we will consider least number of significant digits. Then it will be 5.98. Here 1.3463 bar, 0.25 bar. That we are adding it, then we will get 3.59 bar, 63 bar. Then 63 will have to be converted, and it will come as 3.60. Here 5.98 can be 5.99 also. Only one uncertain digit is around. Rule of multiplication of significant digit. The number of significant digits after the multiplication or division of two or more measurement in the result will be equal to the least number of significant digits in the number multiplied by. Like 1.234 bar, 1.2 bar. Then we have to consider 1.2 bar number, that is 2. Then after multiplication 2468 bar, 234 bar, adding it 1.48 bar, 0 8 bar. Then we have to take it as after 4 के बाद कितना है 8 बार है, इस वजह से इसमें एक बनाते हुए 1.5 बार. Find out the total surface area of a cuboid in a proper significant digit with the following dimension. Length equals to 2.52 bar centimeter, breadth equals to 1.55 bar centimeter, height equals to 2.2 bar centimeter. Surface area equals to 2 into LB plus BH plus L1. As we are multiplying it, we are getting like that 3.91 bar, 3.4 bar, 5.5 bar, and multiplying it to 5.6 centimeters. The number of significant digits will be 3. So while multiplying, we have to take care of that this number of significant digits. Find out the density of the cube. Length is 4.5 cm and mass is 2.5. Since length is 4.5 and mass is 2.5, volume equals to LT, that is 91 cm cube. Then density equals to mass by volume, 2.5 mm, that is equal to 2.7 into 4 gram per cube. The number of significant digits will be 2. Our length is also having 2 significant digits. Okay. Now coming to the errors. Experimental determination of value of G using simple pendulum. T equals to 2 pi under root L by G. G equals to 4 pi square L by T. Now calculating G. 9.78. Error delta G equals to minus 0.01. 9.82. How minus 0.01? 9.788, 9.82, 9.81, 9.75, 9.79. That is total 48.95. On taking its average 48.95 by 5, that is coming to 9.79. 9.79. 9.7 variation we are looking at here. G 9.78 and the average value is 9.78. Then minus 0.0. 9.82, that is 0.03 plus 9.82, 0.02, 9.7 minus 0.04, 9.7, 0.0. As a result of the variation, that is maximum, that is taken as the plus minus, that is 9.79 plus minus 0.004, 0.04, that is the absolute. We take the maximum error as the absolute error in the experiment. maximum extent to which the experiment can give a correct result. Definition of absolute error: the maximum actual error that can occur in an experiment. That is called as absolute error. Relative error: it is the ratio of the absolute error to the actual quantity. That is relative error equals to delta G by G, 0.049.7. Percentage error: relative error into 100 is percentage error. Addition and subtraction of physical quantity with error. If we are going to add these two quantities with this error, then we have to take maximum value of the error and we have to simply add the number. That is L1 plus L2 is 14.8 and the variation is plus 0.4 to minus 0.4, that is plus minus 0.4. L1 minus L2, there is a difference also, and the error will not be changed. It will not depend on how it is subtracted or added. It only depends on the variation that it can achieve by subtracting. 9.6 plus minus 0.4. Two physical quantity can be added or subtracted, but the error are always taken as a maximum error, which is the sum of errors of the two same quantity. Now our next question. Two resistance are given as R1 equals to 10.8, 0.2 ohm plus minus 0.2 ohm, R2 is 0.6.4 ohm, and the absolute relative and percentage of the resistance are combined in series. The equivalent resistance is 19.4 plus minus 0.6, absolute error 0.6, relative error 0.6 by 19.4, that is 0.03, and percentage error is 3.1%. Multiplication and division of the physical quantity with error. At n plus minus delta n, a plus minus delta n, b plus minus delta n, x plus minus delta x. F equals to n, at a p by x. Now taking log of ln f, then n, then a, then b minus ln x. But as we will take the df by f, then it will come like plus minus del eta, like del eta by del eta plus minus del I by plus del b by b minus plus del del I by f plus minus b bar del eta by eta del I by a del b by b del x by x. Thus for relative error in the measurement of f is the sum of relative errors. That is dl by l 1 by 2 power dg by d 1 by 2, that will be addition, no subtraction. The dimension of the cuboid are given as follows: L is this, B is this, and mass is this. Find out the relative error in the measurement of the density and the absolute error in the measurement of the density. The density equals to mass by volume. Mass is given LB and volume. That is equation 1. Now ln rho is m LB inch. D rho by the dm by m, df by l, dv by b, h. That will come out to become 447. Percentage error will be 44.7%. The error in the measurement of the length of the simple pendulum is 4%, and the error in the measurement of the G is 6%. Find the relative error in the measurement of the time period and the absolute error if L is 20 centimeter, 0.2 meter, G is 9.8 meter, del T by T is half del L by L, del G by D, half del L by L by L to 9, del L by L is 4 and del G by D is 6, 4, 6, 10, that is 5%. Relative error will be 0.05. T equals to L by D. That is 6.2 by 7. delta t equals to 0.5 into t. That will come as 0.05 into 6.28 by 7 into 897. From multiplying it will come like 0.0457. That is the answer. A physical quantity P is given as P equals to A B square under root C into dq. Del P by T equals to del A by A 2 del B by B half del C by C plus 3 del B by D. On adding all, as there is given A, B, C, D are other physical quantity having errors 2%, 1%, 4% and 1%. On adding these all, we have 0.09, meaning it's 9%. Del P equals to 0.09 into P. On calculating P, we have the value of P is 27.5432. That as we calculate 2.478888. Then P equals to P out 27.5432.4788. Here error added to 7 which makes an uncertain. तो यहाँ इस तरह से तो नहीं कर सकते हैं. 27.5432 है तो 5 को भी चेंज करना पड़ेगा. 27.528 हो गया. 2.47888 2.2 हो गया. ठीक है, केयरफुली 24.3 plus 1 and we have to do 24 plus minus 1. Error always occur in the uncertain digit and only one uncertain digit is allowed in the significant number. Here P must be rounded off the unit place. For example, R is 2.5 plus minus 0.2, R2 is 1.5 plus minus 0.1, R equivalent equals to R1 into R2 by R1 plus R2. From here dr equivalent equals to dr equivalent by r equivalent का square dr1 by dr1 by r1 का square dr2 by r2 का square dr equivalent r equivalent का square 0.2 by 6.25 0.1 by 1.44. Absolute error we know 0.2.1 and its value given. On calculating it will give you 0.102. R equivalent equals to R1 R2 by R1 plus R2. That will give 30 by 37. So dr equivalent equals to 0.102 to R equivalent by square. That will come as 0.07. So now the next topic is vernier calipers. So here we can show you, one is the main scale and the bottom one is the vernier scale. The diagram for the situation that there is no gap between curves. Gauges के बीच there will be no gap. So the 10/30 division of the vernier scale is coinciding with the 9 division of the major scale. Then 10 division of vernier scale division equals to 9 mm. Then one vernier scale division will be 0.9 mm each. Just count. The minimum measurement done by an instrument is called least count. Least count equals to L1 minus L2 and 1 main scale division minus 1 vernier scale division. That is 0.1 mm. Now here is as shown means दिखाया गया है जहाँ पर नीचे वर्नियर स्केल है ऊपर मेन स्केल है. तो 50 डिवीजन मेन स्केल पर 15 डिवीजन coinciding with the vernier scale and the 8th division of the vernier scale is coinciding with the main scale is 1 digit. Then Main scale reading will be 50 mm plus vernier scale reading will be delta F 15 mm plus L1 minus L2, यानी 8 main scale division minus 8 vernier scale division, that will be 0.1, 1 main scale division minus 1 vernier scale division, that will come out as 15.8 mm. In order to measure the diameter of the sphere, a vernier caliper is used. It is found that 7 division of vernier scale coincide with the 26 division of the main scale. If the vernier caliper is the standard construction, find the diameter. This count is 0.1. Length of diameter 26 minus 7, that is 19. 7 is coinciding with vernier scale, that is 7 into 0.1, that will come out to be 19.7. In a vernier caliper, it is found that each main scale division is of 0.5 and there are 10 divisions on the vernier scale with the 10 division coinciding with the 9 division main scale. Find the estimate. Since 10 division of the vernier scale is 9th main scale division, so 1 division of the vernier scale is 0.9 main scale division. Least count is 1 main scale division minus 1 vernier scale division, that is the common formula. Then 1 main scale division is 0.5, our vernier scale division is 0.9 into 0.5, 0.45, that will give you 0.05 mm. Using the above vernier caliper measurement is made in which fourth vernier scale coincides with 41 division of the main scale. Find the reading of the main. 41 minus 4, that will be the main scale reading, into 0.5 is the each division, then it will give you 18.5. Vernier scale, 4th into least count, 4th into 0.05, that will be 0.20. Then reading will be main scale reading 18.5 plus 0.2, 0.7. Error in the vernier calipers. There will be positive error, there will be negative error as shown. In positive error, there will be delta x equals to L1 minus L2, 2 main scale minus 2 vernier scale, that will be 2 into least count. If there is least count of 0.1, 0.2, it is the positive error which measures greater than the actual value. It is the positive error shown here. Vernier scale is leading by delta x. It is the positive error which measures greater than the actual value. Negative error, in which vernier scale main scale is leading the left end of the main scale is beyond the vernier scale. Then here will be 6 main scale and a 6 vernier scale. 6 into least count, that will be capital N minus a small n into least count. Now come to the question that is very important. In a vernier caliper, when the gauge are coinciding, the 0 of the vernier scale is 40, the left of the main scale, and 7 division of the vernier scale is coinciding with the main scale. If the vernier caliper is of standard valuation and measures the diameter of the cylinder in which the 4th division of the vernier scale coincide with the 26th division of the main scale, find the exact diameter. Now 0 error, delta x is minus of n minus 1 is 10 minus 7, because in vernier caliper, when the gauge are coinciding, the 0 of the vernier scale is 10th the left of the main scale and 7th division of the vernier scale coinciding with main scale. Then 10 minus 7, that will be 0.3 mm. Total reading equals to 26 division coinciding with 4. Vernier caliper standard valuation measures the diameter of the cylinder in which 4th division of the vernier scale, that is 4th division of vernier scale coinciding with 26. 26 minus 4, that will be 22, plus 4 into least count, that will be 0.4, 22.4. The actual value will be total reading minus delta x, 22.4 minus or minus 0.3, that is 22.7. That is the answer. That is the answer. In a vernier caliper, each main scale division is of 0.5 mm and 10 division of the vernier scale is shifted slightly right to 9 division of the main scale. When the gauge are coinciding in taking a reading, it is found that 7 division of the main scale coincide with the third division of the main scale. Find the actual value of the reading in the gauge coinciding with fourth division of the vernier scale coinciding with the main scale. One main scale equals to 0.5, discount equals to 0.05. And del x यानी e equals to 4 into least count 4 into 0.0, that is 0.2. Reading from main scale 16 into 0.5, vernier scale 7 into 0.05, that will come 8.35. Then actual value will be reading minus delta x, 8.35 minus 0.20, that will be 8.15. That is the answer. A vernier caliper has 1 mm mark on the main scale. It has 20 equal divisions on the vernier scale, which coincide with the 16 main scale. Find the least count. 20 division of the vernier scale, 20 division of the vernier scale, 16 main scale. 1 division equals to 0.8. On vernier scale division equals to 0.8 mm. This count equals to 1 main scale minus 1 vernier scale, 1 mm minus 0.8. That is 0. The diameter of the cylinder is measuring using a vernier caliper with no zero error. That is found that during the measurement, the zero of the vernier scale is between 5.1 cm to 5.15 cm of the main scale. The vernier scale has 50 division equal to 2.45 cm during the measurement. 24 division of the vernier scale coincide with the 1 cm. Find the diameter. One vernier scale division equals to 24 by 5 by 15.49 mm. One main scale equals to 5.15 minus 5.10, and 0.5 centimeter, that is 0.5 mm. 0.05 centimeter, that is 0.5 mm. Let's count with 1 main minus 1 vernier. 0.5 minus 0.49, that is 0.01. And actual value of main scale reading plus vernier scale. 5.10 centimeter, 24 into least count, 5.10 into 24 into 0.01, that is 51.24 mm and 5.124 centimeter. That is the answer. Screw gauges. As the screw moved outward and inward, one full rotation on the circular scale corresponds to one division on the main scale. Hence, least count LC equals to length of one division on main scale by number of division on circular scale. If the main scale division is 1 mm and there are 100 circular division on circular scale, then least count equals to 1 by 100, that is 0.01 mm. Then total reading equals to main scale reading, that is 2 plus 45 into 0.01, that is 2.45 mm. Coming to the next question, in order to measure the diameter of a wire in a standard screw gauge is used, the circular scale rotates 4 complete rotation and a partial rotation in which 23rd division of the circular scale coincide with the main. Find the diameter. Main scale reading, that is 4 plus 23 into 0.0. Pitch. The distance between two main scale divisions is called pitch. Distance between two main scale divisions is called pitch. Now here is the question. 8 complete rotation of circular scale are equal to 2 mm. 8 complete rotation, it is 2 mm. If the circular scale has 50 divisions, find the diameter of the wire which required 10 complete rotation and a partial rotation in which 24 division of the circular scale coincide. 0.25 by 50. Why? 2 by 8, that is 0.25. Total division is 50, that is 50 in 0.005. Pitch equals to 0.25 m, that is the answer here for it complete rotation. So fluid scale is equal to 2 mm, that is 1 point. Total reading equals to main scale reading into circular scale reading, 10 into 0.25 into 24 into 0.005, that is 2.62. 8 rotation equals to 1 rotation of 0.25 mm. This count equals to 0.005. Minus scale reading 2.5. Circular scale reading 0.01. 0.62, that is the answer. Zero error in a screw gauge. Zero error occur in a screw gauge when the circular scale 0 does not coincide with the principal line, when there is no gap between the heads of the screw gauge. The screw gauge does not have any zero error, as shown here. Positive zero error. 0 is below the indicator, and that is 4 is one side, and here 0 is above, that is 97, that is negative error, negative zero error. Here error equals to n into least count, here error equals to minus of n minus n into least count, that is answer. When the heads are coinciding with the 49th division of the circular scale of the 100 division, coinciding with the reference line, this is the screw gauge used to measure the diameter of the wire of the 16 complete rotation and partial rotation in between 63rd division coincide with the main line. If the pitch of the screw gauge is 0.5 mm, find out the structural diameter. This question you have to do homework. I hope up to here there will be no confusion. If there is any confusion, you can comment in the comment.